This is the third example problem in this topic. It's a problem from the leetcode website. It's called the relative sort array. And this problem, we did not enter it into HackerRank. So if you want to solve this problem, you can go to leetcode to do that. So you click on the link. It will go to this. I loaded this before. So here's the problem statement. You are given two arrays, and the array of the second, the element of the second arrays are distinct, and the goal is to sort the elements in the first array so that the relative ordering of items in the first array is the same as that in the second array. So more precisely, for any elements that appear in the second array, they should appear in the same order in the first array, and these should be put in the beginning of the first array. And then anything that in the first array but not the second, they should appear in their ascending order. So I think it's best to look at the example. So this is the array 1, and array 2 include 2, 1, 4, 3, 9, 6. So then these 2, 1, 4, 3, 9, 6 in the output should appear in the beginning, 2, 1, 4, 3, 9, 6. And also the number of each element should be the same as the number of the time that the element appears in array 1. So 2 appears 3 times in array 1. So there should be 3, 2 here, followed a single 1, 4, 3, and so on. So after these elements that are already in array 2, the rest of them should appear in ascending order, so 6, 7, 19. So the parameter for this problem is both array are bounded by 1000, and also the elements of the array are also bounded by 1000. So I encourage you to pause the video and think about this problem, see how you solve it. Okay, so assuming that you have thought about the problem, so the parameter size means that the quadratic algorithm is totally acceptable. But but one can do better than quadratic algorithm. So let's try to solve the problem assuming these parameters will be, say, 10 to the 6, 10 to the 7. So both the length and the number, they can, let's say, go up to 10 to the 6. So how would you solve that problem then? So generally we want to solve, for any input we want to be able to run within a second or two. So the reason I chose this problem is to introduce the concept of counting sort. So the idea of counting sort is relatively straightforward, in my opinion. You count an array you sort an array by counting how many times each of the element appears, and then because we are when there is a natural order for all the elements, then we just enumerate through all the elements in the order, and then just output how many times it appears. So similarly for this problem, we have the element in array 2 in this order, and there's really doesn't seem to be any good way to encode this ordering in any other format. So we just work with the array 2 for the ordering of this element. So that means we'll just go through this element one by one. So if we go through the element in array 2 one by one and try to generate the output, then we need to know, we look at 2, we know 2 should go to the beginning, but what we need to know is how many times 2 appears in array 1. So we'll just be constructing, we need to count how many times 2 appears, how many times 1 appears. And because the elements in the array are in a limited range from 0 to say 10 to the 6. So then we can simply create a array to count the number of times each of these elements appears. So this is known as a histogram array, and it's a very useful thing. And I think we've used similar things when we deal with voting in topic 3. So if we have a histogram array to count the number of times each element occurs, then it's pretty straightforward how to do it. And in fact, even when the elements in the array are in a bigger range, so for example, we could have each array contain up to 10 to the 6 element, but then the element can be up to 10 to the 9. So in that case, we cannot use an array to store the histogram. So, but later, I think in the last topic, we'll introduce data structure to handle this. Essentially, we can use a map to do that, which will which sort of store all the element and then sort them, and then it's a more sparse array, if you will. So instead of having something for every indices, we only have value for some of the indices in an array. And for the other indices, the array doesn't contain any useful information. So for such a sparse array, we can use a map to either a tree map or a hash map. So in C++, it'll be either order map, either just a map or an unordered map. So we'll talk about that in topic 10. So now going back to this problem, so these slides just go over the idea we talked about earlier. Let's look at the solution code. So to make the code a little bit more succinct, so I use the VI to stand for the type of vector int. So we are given 2 input array. So here, because I'm still solving the problem specified here, so the max value is basically the size of the array for storing the histogram, because value goes from 0 to 1000, so max v is 1001. And h1 is a histogram for array 1. Answer is a vector that I'm going to construct that, and then as a result, and then return. So to enable the efficient construction of the second part of the array, sorting everything in array 1 that do not appear in array 2. So I use a auxiliary data structure to remember whether an element appear in array 2 or not. So then the first part is to construct the histogram. So go through every element in array 1. So add 1 to the corresponding counting, to the count of that element. So this takes the time linear in the size of this array. And the second loop, I will, for each element in array 2, I will remember the fact that this element has appeared in array 2, and then I will add this element to the beginning of the output, and the number of time I add is determined by the histogram. So actually it's a little bit interesting what is the running time for this part, because this part, the number of the inner loop executed depends on how many times it appears in array 1, so it's sort of changing. However, the total number of time this pushback happens will be bounded by the size of array 1, because for everything that appears in array 1 once, we're going to execute this once. Something appears in 3 times, we're going to execute this 3 times. So the total number of time this executes is bounded by the size of array 1. So this whole loop is linear time. So then the last part is I will go through all the values in max v. Then if this value does not appear, then does not appear in array 2, then I will add it to the output, because if it's already in array 2, I have already added earlier in this part. So this part generate the rest of the array where are the element in array 1 but not array 2 sorted by the natural ascending order. So the complexity of this part, the running time of this part, is a upper bound of either max v or the size of it's bounded by max v plus the size of array 1. So if array v, max v is very large, because I need to do something for every max v. So if max v is very large, I need to use something else to do this instead of enumerate through all the value and check whether they appear in array 2 or not. But this line of adding things to answer, they are bounded by the size of array 1. So for the parameter of this problem, whether the original is 10 to the 3, just 1000, so the complexity is linear in 1000. Okay.